Right, in this video we give just a quick overview of what we mean by surface area and surface area as a surface integral. The surface integral, a surface integral that we've outlined so far is that we're going to do a double integral over a surface. We're going to do a scalar function f, and then we're going to integrate with respect to d sigma, where d sigma is equal to the magnitude of RU cross R sub V. Okay? And S is a surface that is given by the parametric form R of U of V. So once you know the parametric form of your surface, you can find d sigma by computing the magnitude of the cross product of the partial derivatives of the surface. Okay? And we know that RU cross RV is the normal vector for the surface, and it basically gives the direction that the surface is pointing in. Okay, so if you compute the magnitude of that vector, you will get d sigma. Okay, and the question is to kind of get an idea of where the surface area fits in. If we take this surface integral and specify it to the scalar function f is equal to 1, we will get a double integral over the surface. Here is the surface in orange, right? We will integrate 1 d sigma, and that simplifies to the magnitude of RU cross RV du dv, where you integrate over u and v, where you know what the parameters u and v are, or can be found in the problem. Okay, so the thing to recall here, there's a big idea to recall, right? That very early in the course, we looked at vectors, and we looked at the idea if you took a vector v and a vector w and cross producted them, that you would get a vector perpendicular to both of them. But that if you computed the magnitude of the cross product, that this would give you the area that was given by the parallelogram made by the vectors v and w. So that would look like, here would be the vector v, here would be the vector w, there would be a parallelogram made by those two vectors, and the magnitude of the cross product would give you this area. Okay. So what is special about this double integral shown here, the surface area integral, is that we are thinking of RU and RV as the edges of these vectors right here are the edges of these parallelograms that make up the surface. So RU and RV at different points, RU and RV, are the edges of these parallelograms. Okay, and the part of the surface is made up of these different planes, and those parallelograms of those planes are made up of vectors on each edge, which is RU and RV. So if you compute the magnitude of RU and RV, you are essentially computing the area of these little tangent planes right here. And it then is up to the double integral to basically perform an accumulation of surface areas of those little planes, right? So that is why this double integral is what it is for the surface area integral. D sigma is essentially the surface area of a little piece of the surface, d sigma, and by doing a double integral of d sigma, you are essentially adding up surface areas. Okay, and if you integrate over u and v, add up surface areas over the values of u and v that make up that surface, you will get the area of the whole part of the surface being described as a bunch of little rectangles that have been added up. So ends this introductory video to why the surface area integral is what it is.